Hello again everyone, this is Chris Ostrowski from About, and in this video lesson we're going to take a look at an absolutely essential piece of working with Oracle databases, and those are two files called the init.ora file and the sp file. As an Oracle database administrator, one of the key things that you're going to have to understand is how to create databases and how to monitor databases on a regular basis. The init.ora and the sp file are going to be absolutely essential for your understanding on how your database instance is working and performing. And this video we're going to take a look at some of the basic things that go on inside the init.ora and the sp file. This is a very high-level video. We're not going to drill into a lot of the details as we look at things like performance tuning, backup and recovery, security. We'll revisit these topics. We'll go back and look at the init.ora file and how to change parameters. But this video is really geared towards giving you a very high-level overview of how each one of these files is important and understanding how these files work for when you create and monitor your databases. So this video we're going to take a look at a couple of basic topics. What exactly is the init.ora file? We'll take a look at a sample init.ora file so we can take a look at some of the values that are in there. And as you'll see, it's a pretty simple file. It's just a basic text file with pairs of values and parameters and values that are specified there. We'll take a look at the default values that go along with creating a database. And we're going to look at something else called an sp file. Sp files were introduced in Oracle a couple of versions ago, and system parameter files are important to understand exactly how they work and why, what the motivation was for Oracle creating these system parameter files. So one of the key pieces of every database is a file called the init.ora file. And the init.ora file specifies parameters on how your database instance is going to work. The Oracle database is flexible enough that you can use it in a wide variety of different environments. Some environments have a lot of transactions. Those are traditionally called OLTP databases, online transactional processing databases, and they're usually marked by very small transactions that happen on a very regular basis. So you can think of something like a bank database that monitors all the transactions that people use at an ATM. Usually those aren't large-scale transactions. Somebody puts in their card, maybe they want to transfer money from one account to another, they want to withdraw some money. So those are usually very small, discrete transactions. Another real common way of using an Oracle database is in a data warehouse. Data warehouses usually have tons of information put in them, and they're used for analytical processing. And then we have the acronym OLAP, Online Analytical Processing, and those databases are usually geared towards very large transactions, where we'll talk about somebody saying, okay, I want to look at all of the transactions for the fiscal year of 2013, and we want to see trends that are going on inside our organization, maybe inventory trends or buying trends if we run a retail company. So those types of queries that go against the database are usually going against very, very large data sets, where we want to see, how many of widget X I sold over the course of 2013. Are there any seasonal trends that go along with widget X? Because we have these very wide-ranging ways that people can use an Oracle database, the init.ora file can be modified to optimize the database for those types of transactions. Are we doing a lot of little transactions where we have like a transactional processing database, OLTP, or do we have these large data warehouse analytical type transactions where we're reading a tremendous amount of information, we're summing, we're doing a lot of different aggregates on what we have inside of our database. And the init.ora file can be tailored so that our database performs better under each one of these different circumstances. So what are some of the things that the init.ora file helps specify? It helps specify what the SGA is going to look like. If you watched our video on Oracle architecture, you know that the system global area is a chunk of memory that Oracle allocates upon startup, and it tries to do as much work as it possibly can inside of memory. Doing things in memory is much more efficient than doing stuff on disk. Memory is much more expensive, however, so we can keep our entire database on disk usually, but it's almost impossible to keep that entire database in memory. That would be a great scenario if we could do something like that, where the only time we ever actually wrote anything out to disk is when we start up the database or when we shut down the database. All the processing would happen in memory, but that's not realistic. Most databases are way too big to fit in memory, so we have to keep most of it on disk, and we just keep the essential parts as we can in memory. So the init.ora has parameters that are going to specify what the size of our SGA is and what the SGA looks like. It also specifies things for memory processes, performance tuning, where the various files that make up our instance are going to be located, things that handle date, time, currency, the language of our database. In 11gr2, there's over 300 different parameters that we can specify inside the init.ora file. Most of the parameters inside the init.ora file can be changed. Some of them can't after we've created our database, but most of them can be changed and adjusted. Some of them can be changed and adjusted on the fly while the database is actually up and running. We're going to take a look at that coming up. But there are some parameters that can be changed, some can't. So even if you make a mistake, and I shouldn't even call it a mistake, even if you do your best estimate as to what your database is going to look like, and things change in the future for whatever reason, you're not locked into those changes for the most part. For the most part, you can go in and change the parameters as the circumstances change inside your organization. So let's take a look at what a typical init.ora file looks like. This is just a small piece of it. As you can see, there are pairs of parameters and values. So in the first line we have here, everything that begins with a pound sign is a comment. So the first line here we have something called control files, and because we can have multiple values for our control files, they're enclosed in parentheses. The next line, db_recovery_file_destination, shows a single parameter value pair, and that's mostly what we see inside the init.ora. You can see there's different values that we have for compatibility, memory target, processes and sessions. One of the key things to remember is that all parameters, except one called db_name, which is obviously the name of our database, all have default values. So in a simplest case scenario, I could set up an init.ora file that has one line in it. dbName equals production or sample or development or whatever it is we're talking about. When my database is up and running, how do I actually see the values? There's a view inside all Oracle databases that allows me to see the values that make up my Oracle instance. We can write a real simple SQL statement, select name value, and you can see there's this view here called $parameter. There's more columns in this particular view, and we're going to take a look at that in a second. But if I just want to see the name and the values in $parameter, I can run this SQL statement, and again I have to have DBA privileges in order to see this view. But I can see all of the different names of all the different parameters, and like we said, in 11gr2 there's over 300 of these, and the values that go along with it. One interesting thing to note is that almost all of the parameters are in lowercase. So if you want to look for a specific parameter, if I had a where clause on that select statement and I wanted to see something like ASM power limit, I'd have to make sure that I specified the name in lowercase. It's just one of the unusual quirks that go along with the init.ora file and the values inside the $parameter view. We can alter these init.ora values. If something serious happens inside of our database and we need to change it, we can always shut down the database, modify the init.ora file, start up the database again, and those new parameters will automatically be in place. But there are some init.ora values that we can actually change on the fly. If we run this statement, where we select the name and the value from $parameter, but we look at these two additional columns. One is called is ses modifiable and is sys modifiable. Is ses modifiable stands for is this particular value session modifiable, which means I can modify a particular value just from my session. Is system modifiable means that I can modify this particular parameter at the system level so that it affects everybody who's connected to the database. Here's some of the values, and I didn't print out everything because again there's over 300 different parameters that go along with the 11GR2 database. But here's an example of some of the values that are out there, and you can see that of these 6 that happen to be on this page, none of them can be modified just at the system level. They're all set to false. Some of them, however, 4 of the 6 can be modified at the system level, which means that on the fly I could actually change the value of AQ_TM processes or archive leg target. I can change those on the fly if I needed to. Gives DBAs a tremendous amount of flexibility. This was just introduced in the Oracle database a couple of versions ago. Before we had this capability, the only way to change the init.ora parameters was to make the changes, shut down your database, start the database up again, and it would pick up all of those new values. With this new capability, we can actually go in and make changes to the database on the fly. So if session equals true, if session modifiable equals true, you can change the parameter for just your session with the command alter session set parameter equals value. If system modifiable equals immediate, you can change the value for the entire instance. Again, that's not just for your session, that's for everybody who's connecting on the system with this command, alter system set parameter equals value. And you can see there's a scope switch that goes along with this, memory, spfile, or both. The next slide we're going to take a look at what each one of those means. So what does scope have to do with altering the system? We looked at this command a second ago, alter system set parameter equals different value, and then we specified the scope. What is the spfile? It's obvious what memory means. It means changing what's going on inside the database at the particular moment. But what is this spfile? And what is the both switch? What do those things do? Oracle has introduced this new concept. And again, this has been around for a while. This has been around since I think Oracle 9.9 of this thing called the system parameter file. The system parameter file is a binary version of the init.ora file. It is not something that's intended to be edited with a text editor, as opposed to the init.ora file, which is designed to be edited with a text editor. Why does the spfile even exist? DBAs for a long time had this issue with changing parameters inside the database. A lot of times they would do an alter system and they would change a parameter inside the database and then kind of forget about it. So imagine you made all of these different changes to your database. It's been running for weeks or months, and you've made all of these different changes to your database. You've done the alter system command and you've changed a bunch of the parameters around. But again, you're busy as a DBA and you kind of forgot about all these different changes you made. And then for whatever reason, you need to shut the database down. Maybe the system's going down for maintenance. Maybe the server is getting an operating system upgrade, something like that. You shut the database down. Well, when you start it up again, it reads all of the values in the init.ora file. You've lost all of the changes that you made there, unless you were smart enough to remember, oh, I just made this change to the system. I have to go to my init.ora file and manually make the changes there. If you've forgotten all those pieces and you start up your database again, it reads all of the old parameters and you've lost all of the changes that you made. So Oracle came up with this system parameter file, and again, it's a binary file. What this allows you to do is, if you issue the command at the top of the screen, alter system, and you change a parameter, if you specify the scope is the SP file or both, what happens is the change not only is made inside the database if you specify both, it's also changed dynamically inside the SP file, the system parameter binary file. That's important because, again, months from now or weeks from now, when you have to shut down your database, or even worse, if the database gets shut down, that's not a planned outage, if you have a power failure or something happens and you have to start up your database again, you don't lose all of those changes you made to your database, to the database structure. So the SP file is a binary version, and it allows you to issue this alter system command, change parameters, and have them dynamically made inside the binary file also. So there's a real simple way you can go ahead and create an SP file if one isn't created for you automatically. The simple command is create SP file, and you specify an SP file name, and you say from the P file. And the P file in this example, the parameter file, is going to be your init.ora. And you can see in this example it's called init.prod.ora. You don't have to name it that, but that's a common way of doing it. Init and then the name of your database with an ORA extension. So if I have both of these files, if I go ahead and I issue this command, so then I have an init.ora file and I have an SP file, what does Oracle do when I actually start up the database? If both the SP file and the init.ora file exist, Oracle will read the system parameter file and ignore the init.ora. So if the SP file exists, any changes I make in the init.ora, Oracle is just going to ignore. It's going to read that first. If it can't find a system parameter file, then it'll look for an init.ora file and read the parameters from there. So again, if I specify scope equals memory, we've changed the parameter in memory, but we haven't changed it inside the system parameter file. So if I don't make a change to my init.ora, if I don't manually go in with an editor and make that change, the value is just going to revert to the value that's in the init.ora file. I can also say scope equals SP file, and that'll change the parameter inside the binary file. Once the instance is restarted, the new value will be the new value that we just specified in there, but it doesn't make the change in memory. This is important for those parameters that you can't change dynamically. If we have something that I cannot change dynamically, but I want Oracle to pick up the next time we start, we have to say value scope equals SP file. If I say both, then changes are made both in the parameter, in memory, and in the binary SP file. You certainly can create your database from scratch, but Oracle gives you this really cool tool called the DBCA, the Database Configuration Assistant. By default, the Database Configuration Assistant will create an SP file for you during its creation process. It's nothing more than a graphical wizard that'll ask you a whole bunch of questions about your database, and then it'll provide you with information. It'll write out all of the information for you and actually create and start up your database. The Database Configuration System will create an SP file by default unless you tell it not to. The location is going to be in Oracle Home Database. And one of the key things to remember is that the opposite command also works. In the previous slide, we had create a system parameter file from a P file, an init.ora file, we can also do this in reverse if we need to see all the parameters, if we want to see what this looks like. We don't have to see what this looks like if we use the database configuration assistant. It'll create the system parameter file for us automatically. It doesn't create an init.ora, it doesn't create a P file for us automatically, but we can reverse engineer one if we need to. So in this video we took a look at all of the different things that go along with the init.ora file and how that file is absolutely essential for creating our database. In subsequent videos we'll take a look at the individual pieces of performance tuning, backup and recovery, security, tie those back to values that we find in the init.ora file, and see how we can modify those to tune our database so that it works perfectly in the circumstance of whatever we need inside of our organization easily.